Hi everyone, welcome to my talk about publishing, citations, journal metrics, and peer review. It's a lot of topics today, maybe too much, but I really wanted to get you into thinking about publishing and specifically citations this week. And there's a lot of ways that scientists talk about citations that I want to make sure that you are up to speed as first-year graduate students so you can use some of the citations well. And with that, we're going to also talk about citation practices and then a little bit about peer review. I'm probably going to short peer review just a little bit. We're going to talk about conflicts of interest and things in coming weeks, so I think we'll cover it there too. Okay, so think about this case study for a moment. There was an article out, you'll see at the bottom, about this. So imagine that somebody is an editor of a scientific journal, and for years they ask authors that they edit the journals to add citations to their papers. This was actually done by a biophysicist named Ku-Chin Chow, I think, who did this. And so in just about every time he reviewed a paper, like for another journal, he asked them to add 35 citations, 90% to his own work. That was what they found when they did an investigation. But then as an editor, so there's two parts here. As a reviewer, maybe you would review for any old journal and you say, oh, cite my papers. But as an editor, he handled probably hundreds of papers a year. And he routinely asked also for his papers to be and algorithms to be cited as well. And a couple of years ago, he was in the top 10 of cited researchers, and they took him out because they found a high rate of self-citation. The funny thing is there's really nothing in the scientific world to really go back and account for this or take off those citations. But when people find this, of course, I think when you look at an article like this, you think, wow, that's really wrong, right? You shouldn't use your duty as a peer reviewer to ask people to cite yours, or your duty as an editor to ask people to cite you more and more. So we're going to talk about citations, though. Why would you do that, right? You want to be one of the world's most cited chemists, or that kind of thing, right? So, looking for glory, you inappropriately use your influence as a reviewer and as an editor. So why are citations important then? The first most is that they establish what's been done previously in the literature, right? So what have people done before? You should be citing that. And so it gives credit to those people, right? It establishes who is working in this field, what have they done? And so when you miss a key citation in an introduction or in a discussion part of a paper, right, it can show a lack of familiarity with the field. But also people can feel slighted. Well, I did a similar study and they didn't cite me. And so it can cause a lot of angst in science. And in fact, one of the case studies I assigned to this Chem 70-20 class kind of talks about that. What if somebody doesn't cite you? And so it's important when you're writing papers, quite frankly, to get your citations right, not to just be kind of arbitrary. Well, here's a paper, but to do a systematic peer review of the literature and make sure you're finding the most important, relevant, up-to-date kind of citations, but also the historical ones if somebody started a field. See, and there's always going to be disagreement, though, about how important certain studies are as background knowledge, something that somebody else thought, well, they should have cited my paper. That's clearly related to theirs. Other people say, oh, it's only tangentially related, right? It's not that important, and that's why I didn't cite it. So there's always a lot of controversy about citations, quite frankly, in science. And then nowadays, I think there's even more angst about citations because we talk about personal publishing metrics, quite frankly, all the time in science. So here's some of the ways people talk about their publishing. Maybe they'll talk about the number of first author publications, like, oh, I published 3 first author publications as a graduate student, right? That would actually be a very good thing to have done. If you're more senior, like a professor, then you might talk about the ones that you were last author on. Or the total number of articles published. I've published 10 articles so far in my career, right? And even when, again, you're a professor, there's this old adage that say your colleagues can't read, but they can count. And so that means that, a lot of times people haven't read your papers, but they can just look at the listing of them, right? And they can count how many, and they can know if you're doing a good job, right? So there's some sort of cachet to having a lot of papers kind of under your belt. And then, as I said, if you want to, my articles not only can I publish a lot, but they're being cited, then people talk about their total number of citations. Oh, I have 6,000 citations, or, this kind of thing. And then for younger people, especially who are trying to go out on the job market, sometimes they'll put in preparation or submitted papers, and I didn't add it here, but they're archive papers, bioarchive, chem archive papers. I can put in the same way, where you're like, oh, I want people to know I have papers coming up, so I'll put these papers on. Quite frankly, I'll tell you that when I'm looking at job searches, these papers don't really count for that much, but they can let somebody know, well, they expect to get 2 more papers out of their PhD. Do they count the same as if you've already gotten them out when you're looking for a job? No. Not even an archive paper, in my opinion. It just is kind of a placeholder for, hopefully we'll get a publication out on this soon. Okay, so let's talk about a couple ways people talk about their citations now. So this person named Hirsch published a paper, oops, I probably should have put the citation, see bad of me, on the bottom of the slide. And he came up with the H index. It's defined as the number of papers that you have that have at least that number of citations. So that's a mouthful, but it's easier to give an example. So if your H index is 23, that means you have at least 23 papers with 23 citations each. This doesn't actually look at anything, though, to do with first author, last author, middle author, right? So you could be, those 23 papers could be you were middle author in them all and didn't make a huge contribution, right? It could be that they were all first author papers, right? So it's very imperfect. But he argued that this was a way to look at both kind of quantity of papers as well as how many times they were being cited and their impact in the field. I followed up and read some about this index, and I found an article that argued that a generally good scientist, particularly an academic scientist, would be expected to go up in H index about 1 per year. And that really influential scientists have a slope of 2, so they go up about 2 per year. And so that's kind of interesting. So because a lot of this, of course, will be based on age, right? If you looked at your professor's H index, and I'll show you how to go do that in a minute, you might say, well, an older professor obviously should have more of an H index than a younger professor, right? But that gives you a kind of idea. How long have they been publishing? Is it 1 per year, 2 per year, something in the middle, that kind of thing. So where do you find your H index? On Google Scholar or Web of Science. And these are particularly good for looking up people. So this is Google Scholar. You can make a profile. I highly suggest that when you want a job, that you do, especially if you're looking for like a postdoc academic job, at an academic institution where publishing is really valued. So this is my profile, B. Jill Vetton. I have my name up there the way I always publish it, so I never use my first name. It has my title, University of Virginia, and this tells you that I verified at virginia.edu, which means just that it wasn't maybe put together by somebody who isn't really me. And then they let me pick some areas, so I picked analytical chemistry and neuroscience. Great. So over here on the right, you can see my citation metrics according to Google Scholar. And you can see that it says, overall, I have 6,244. Whenever I took this a couple days ago, my H index is 39. And my I-10 index is 70. This is, I think, the number of papers that have at least 10 citations. Again, once they came up with H index, they came up with a bunch of other things. Then, if you want to look more immediately, well, in the last 5 years, I have 3,300 citations. My H index is 30, and my I-10 index is like 68. So, what have I done now? And then it has a convenient little bar graph here where it'll tell you how many citations per year. If I was actually in Google Scholar, if I put on my cursor on these bars, it would actually tell me the number. I'm getting like 600, 700 citations per year kind of thing. And then over here, it lists all of the papers by somebody. So this is actually a really good thing if you just want to kind of see what has somebody published recently. If you go to their profile on Google Scholar, you can actually click on this year button right here where it says year, and you'll be able to put them by year so you can see everything I published in 2020. But the default is it comes up with your most cited paper first. And so you can see that I have written a paper that, according to Google Scholar, has 846 citations. It's actually a review article called Carbon Nanotube-Based Electrochemical Sensors for Biomolecules. And this article somewhat went viral and just gets cited and cited and cited. It's kind of interesting to me how much it's been cited. So then the next one is another kind of review article on detecting sub-second dopamine release with fast gas cyclical telemetry. That one was written in 2003. That's when I was a grad student. That was 472. Another review article on psychoanalytical electrochemistry, dopamine and behavior, written in 2003. Again, some of these were, a lot of these articles were with my graduate advisor, who was R. Mike Whiteman, who was a very famous person in the field of kind of electrochemistry. for neuroanalytical. So I'm proud though that that one from my own lab is my highest cited one, right? So you can see the citations. Notice I said a lot of those were review articles, though. That's a hint. A lot of review articles can get a lot of citations. And then over on the side, if you look at somebody's profile, it'll tell you some of the co-authors as well. But this is a really fun way to stalk people, quite frankly. I look at people's Google Scholars all the time. As I said, you can see what they've recently published. You can see how many citations they're getting. You can compare yourself to them. Okay, maybe you shouldn't really compare yourself to them, but you can look at that. So it's one of the easier ways just to kind of look somebody up and see some of their citation profiles. There's other ways, though. So one of the knocks on Google Scholar is that some people think it gives you higher numbers than it really should. And so there's another way. Publons and Web of Science are the same thing. Publons I find it a little easier because I've made myself a profile. Look, there's me, different picture. This is my name. This is a name that I used to have. That was my maiden name. I only have 2 papers in it, but I can claim it. And now you can see it gives me the total number of publications. I have exactly 100. I like that number. And now it gives you your H index, which you notice it says is 34 and 4,779 total citations. This verified reviews they're trying to cite how many times people do peer review now. I don't find it works very well because of some idiosyncrasies. So I've done a lot more than 3 peer reviews, I promise. Most of them don't get linked to my account. But you'll notice my H index is only 34 on Web of Science, where it's 39 on Google Scholar. And so let's compare the two. Again, let's just take those top cited papers, where again the same review on carbon nanotube-based electrochemical sensors. Web of Science has been cited 684 times, where Google Scholar said it had been cited 846. You'll notice the next one is like 328 versus 472, 287 versus 410, and 227 versus 293. And so you'll see there's some discrepancy there, and it's really hard to actually know what the real number is, because I've also been told that in some journals, in some places, Google Scholar is actually missing people. But the idea that they're different might be that they cite different materials. Google Scholar, they claim, cites more things like patents, book chapters, conference abstracts, and a wider set of journals than in traditional indices, right? So a traditional index sometimes decides what journals are good enough to be in that index, like Web of Science, but, maybe foreign language journals or journals, quite frankly, that aren't as well respected. A wider set of journals might be cited by Google Scholar. And so Web of Science is traditionally only traditional type of articles in better, like, index journals. Okay. So the bottom line is I want you to know there's not one right number. But when we try and compare things, like in the department, we try and pick one way to compare by, we'll all compare by Google Scholar, we'll all compare by Web of Science. And these are ways people talk about people, but quite frankly, they're not that relevant to you as an early career individual, right? As a graduate student, what's your H index going to be? 1, 2, maybe 3, right? Kind of thing. It takes a while to build it up. And I don't think that we should be judging people for a postdoc or something based on their H index. But you will hear people talk about it, and once people get kind of further along in their career, it's one of those indices that people talk about and tout, I'm an important scientist because I have an H index of a certain number, that kind of thing. Okay, so I want citations, obviously, because I want a high H index, maybe. But, you say, why are people not citing my paper? Why am I not getting the citations I think I deserve? One of the things can just be time, right? If somebody reads your study and they're really inspired, and then they decide to start a new study to follow up, it could take them years to complete it, right? If they were really, truly inspired to do something new. And so, science isn't always fast. Manuscripts sometimes are written and are already going through a publication process, and they may miss newer citations, right? So something comes out while it's going through peer review, or right as they're writing it up, or maybe they're in the middle of drafts already and they've already written the introduction and they don't see a new paper that comes out. Sometimes when people cite things, they tend to cite what's first, what's best, and what's most recent. And sometimes you just don't hit that sweet spot. Like, it's a good study, but it wasn't first. It's a good, solid study, but maybe it's not the best thing that's ever been invented, and it's not as recent, or that kind of thing. And so sometimes you don't hit that sweet spot. And then journal identity. And we're going to talk a lot about journal metrics in the second part of this talk. But when in doubt, people tend to cite the more high-impact journal. Even though it may not be the better actual article, they're like, well, that was a Nature paper, so I should cite that, right? And so sometimes people just don't cite that. And then there is sometimes a limit on the citations per paper, either word limits, page limits, number of citations. You can't cite everything, right? So there has to be a line. And again, I put that kind of in the case study. Well, you can't cite everything. There has to be a line. What should that line be? And then there's the problem of sometimes when you're an early stage investigator, or just maybe you're working in a new field and nobody knows your lab or your work. And the answer here is to try and have more visibility, right? To go to conferences, talks, maybe social media, whatever you can do to really promote your science so that people know about you, are looking for your papers. Because you wish that people would go and really do a thorough citation of the literature, a search of the literature, and find your paper, right, and cite it. Reality is people often go, oh, I saw a talk by Dr. Benton a year ago, and she was working on histamine electrochemistry. Wonder if she got that paper out, right? And they go and look for it. If they don't already know about it, they might not find it. And then the last one is shenanigans, right? Your paper doesn't agree with someone else's results, so they don't cite it, right? They don't cite, well, here's some papers that have an opposite opinion of mine. Personal feuds, right? People in science sometimes just don't like each other. So I don't want to cite that lab because, I don't like them. Or sometimes it's more like, well, I don't want to cite that paper because it's going to make my paper look less novel, right? Or that kind of thing. So that shouldn't happen, but it probably does happen more than we want to think. So other things about getting cited. There's an idea in science now that again, it's sometimes hard to find the right articles or attribute them to a person whose name is not unique. And this has been a particular problem, quite frankly, with some foreign authors, particularly Chinese authors, where the names written in English tend to all look the same, right? Because we don't use the Chinese characters. And so they started this ORCID to combat it. So you can get, and you should get, before you publish your first paper, an ORCID number. And that's a unique identifier. And so that way somebody can actually go and look you up by your ORCID ID number and find all of your papers. I happen to have a fairly unique last name. If you look up the last name of Venton on, like, say, PubMed, you only find about 2 to 3 other people who've ever published with it. So it's easy to find my papers. But I have a friend in my field whose name is Sarah Elizabeth Jones, Sarah E. Jones. Great. Right, that's about as common an American name as you're going to find, Sarah Jones. And, it's hard to kind of find her publications, et cetera, just by searching by name. So this is a way that you can do it. And so especially if you don't have a unique name or a hard to find name, you can make your profiles on some of these sites and then gather your publications. And then a side note, frankly, particularly to women, but other people as well, is that, if you do change your name, sometimes it can cause your profile to lose your articles. They're better now about having sites where you can collect your articles, but for instance, I published 2 articles under my maiden name, and then I changed my name in my 3rd year of graduate school. And so I've claimed them on some things like Google Scholar, and now on Publons, but if you just went to look and let me on Web of Science, my H index is going to be too lower, because those happen to contribute to my H index, but it won't find them. So everybody has to choose what they're going to do. I don't mind that I changed my name. These things didn't come up back then. But on the other hand, as I said, if you do change your name, you have to kind of understand that people don't always follow you through science, although I know many successful women who have. Okay, so other ways you can make online profiles besides Google Scholars and like that Publons I was talking about is ResearchGate. This is a way sometimes you can have a profile, you can send requests for full text. It'll give you some citation and stats info. I do get people who request things through ResearchGate. Again, it's another place where you can have all your articles together. And then if you're in the NIH field and you want to submit to an NIH grant, you have to have a formal bibliography from a government site. And so they have this thing called MyNCBI. It's a kind of a pain, but it also is a database that can track compliance with the NIH public access policy. So I'm basically forced to have a site on MyNCBI, so you can look me up there too. It's kind of associated with PubMed. so that you can find me. So there's a bunch of places, and there's even more. I can't keep up with them all, and I can't make a profile on them all, but I've tried to give you some of the ones I think that are the most high profile, that when you start to have papers and citations, and particularly, again, when you want people to know who you are and look for a job or that kind of thing, write for a fellowship or something like that, having these online profiles are really, really helpful to you. Okay, so we're going to skip from personal metrics, that's what we were just talking about, how are people going to know about me and my citations. And now we're going to go to the journal impact factor. Okay. So journal impact factor is a proprietary calculation of the Thomson Reuters, publishing group. And so their official numbers are posted on Web of Science every year, about June-ish for the year before. If you want to, you can go to Web of Science, and then you can click that Journal Citation Reports. UVA has a subscription, so you can see that. And the original purpose of these was to help librarians have a metric to decide the quality of journal and publishing decisions, right? That the idea is a higher journal impact factor is the better, but that's not how they're used anymore. They're used by scientists as a proxy for how good a journal you've just published in. So what is the journal impact factor? Again, it's a slight bit convoluted. So you pick a year, and then if you're going to look at the journal impact factor for that year, it's the citations in 1 year to articles published in the previous 2 years in that journal. So for instance, if we wanted to look at the journal impact factor for 2015, we would look at it would be the number of citations to papers published in 2013 and 2014 in that year, which is 2015, divided by the number of papers published in 2013 and 2014. So an impact factor of 1 says that the average article published in those last 2 years got 1 citation in 2015. And so people use these numbers then to kind of compare. So the other thing is that, there's an immediacy to this, right? Citations to older papers don't count. I showed you I had 864 citations, but that paper was written in 2010. So if it got citations now, it doesn't matter. It doesn't factor into that journal impact factor. And so there's a 5-year average kind of that they calculate now as well if you're in a slower field. But faster moving fields, particularly where people see something and publish really quickly, tend to have higher journal impact factors. Journal impact factors are also often raised more by review articles. People like to cite review articles, often in the introduction of papers. Again, almost every one of my highly cited articles was a review article, and those tend to get more citations. So sometimes journals will game the system by trying to publish more reviews. They're also super highly field dependent. A larger field where there's just more published papers being published tend to have a higher journal impact factor, and because there's more potential citations. So it's really dangerous to take a physical chemist journal, say, and compare it to a chemical biology journal, right? Physical chemistry might be a smaller field, might not be as fast moving, right? And so maybe their journal impact factors aren't as high, but they're sort of really prestigious fields. Nonetheless, people use these all the time as a kind of stand-in for how good the journal is. Okay, so the dirty little secret of journal impact factors, and if you go down to this kind of print there I have, is that usually there's a few highly cited articles, and they tend to drive the numbers up, and that most articles actually get very few citations. So here's a graph, again, based on these numbers, and so it just shows you some common biology journals. Let's look at Nature here, because that's a journal almost everyone's heard of. The journal impact factor for Nature is 38, meaning, again, if this was 2015 for this article and this data, that in 2013 and 2014, the average article got 38 citations in 2015. Wow, that's huge, right? But then you see that 75% of the articles didn't get that many, right? And so a few of them probably got hundreds of citations, and many of them only got a few. And so this is kind of how it works. The higher journal impact factor ones, like you see down here, like Science, that kind of thing, Nature, often publish pretty controversial ones, and high impact stuff they think is going to get a lot of citations. And quite frankly, the other thing about citations is you can get citations if you're wrong, right? Maybe you write a study and it's not correct, and so somebody writes another study and cites you and says this was not correct. Here's the right answer. So just because an article is highly cited doesn't mean it's good, You can be highly cited because people were citing that you were wrong. And so, again, but people use these all the time as a metric of quality when they probably shouldn't, but you ought to know that they're doing it. Okay, so how are these used? To determine if you're publishing in high-quality journals, they're often used in tenure decisions or hiring decisions, and then again, to implicitly imply the quality of a paper, which is completely inappropriate because your paper may be the best paper that's ever been published in a low-impact, typically low-impact journal. Your paper that's published in a high-impact journal may be really low quality compared to the rest of the papers, right? And so it's inappropriate to do it, but I find that it's used a lot. And I'm going to be honest, there's a few cultures and countries around the world where journal impact factors are way inappropriately used, quite frankly, for graduation. So I went on a trip to China a few years ago, and you had to publish in a certain journal impact factor sometimes to be allowed to graduate, right? It was one of the sole ways they looked at that in H-index. But they used journal impact factors a lot as a measure of quality, and people were really trying to be in the best journal that they could. And I'm kind of glad that we don't do that all the time in the U.S. Like, I can publish solid things in solid journals. If people read them, I am fine with it. Like, I don't have to have a Nature paper. But a lot of people in the field, they feel like they got to have that Nature paper. That's the most important thing. Okay, so the bottom line for publishing, I think, is that you need to publish quality work and get a good reputation, and hopefully citations will follow. I often find that sometimes just publishing one thing isn't enough. If you never follow up on it, it's bad. But that once you start a line of research, people will start to see it. It'll get noticed, and people will probably publish it. Obviously, it's better to publish career-wise in high-impact journals, but I'm going to be honest, there's sometimes an enormous amount of effort and time that it takes to go into a higher-impact publication, and it's hard to balance getting a paper out there, right? It can take 4 to 5 years of 10 people to work on a Nature paper, right? And even in chemistry, I was talking with a younger faculty member, and he was talking about synthesis, right? And how, maybe to get into JAKs, they would need to prove their synthesis thing works for, 20 different classes of compounds, right? That was really a broad method. But, in reality, his lab had been able to do 3 or 4, and to do the other 17 would take another couple years, and they'd risk getting scooped, right, if somebody saw their talk or somebody else thought of it, right, so they didn't get it in JAKs, but they got it in a reasonable organic or inorganic journal, right? It's tough, right, to know when you should aim for the really high-level one or when you should say, it's okay, this is a solid paper, a solid effort, I should just get it out. And so I want to tell you some good news. If your journal is indexed in the common databases, which most of the journals you should be publishing in are, anyone can find your paper. So I don't think you necessarily have to worry about having a Nature paper every time, right, in order to be a good scientist. If you want papers that start new lines of research that tend to get lots of citations, right? So if you're really doing innovative things and people follow up, that's the caveat. People need to follow it up. You need to. You'll often get lots of citations. And the contrast is papers that are never followed up tend not to. So if you do a one-off paper on a weird subject, you're probably not going to get a lot of citations. And you can help people find your work now with online profiles and social media. I usually highlight every paper that we publish now on Twitter. I don't know whether people read it off because they see it on Twitter or not, but it can't hurt. So you can, have them on your website, make a Google Scholar, things, that kind of thing. But I always want to tell people that you and your work are not a number. Your impact of your scholarly work cannot perfectly be measured by citation metrics. The but is that people do use them, so you need to know what they are. But it's never perfect. Okay, I'm going to end this with just 2 quick slides on peer review, which is not enough, but I really want to talk about citations more. So just a couple of thoughts on peer review. Here's our thing on whether you should do it or not. Before you accept or decline an invitation to review, you should consider the following questions. Does the article match your area of expertise? Obviously, if you know nothing about it, sometimes I'll get a paper and I'm like, wow, I know nothing about that. But there's a keyword in there, which I think is why the editor maybe sent it to me. Maybe a big database thinks I know about that, but I really don't. Do you have any potential conflict of interest? Again, we'll talk about conflict of interest later, but sometimes being a direct competitor is just a conflict of interest. Like, I hate this group, or they're going to scoop me, or et cetera, et cetera. So if you really have bad feelings, you probably ought not to do it. But if there's something else, like you've worked with them before, or you're close personal friends or something, you ought to tell that to the editor. And then, do you have time? Reviewing can be a lot of work. Now, nobody has time in life. We talked about time management earlier in the semester. Nobody has time, but you want to make sure that you're not committing to do things that you really aren't going to be able to do and that you can't meet the deadline. So here are a few final ones. If you were to write a peer review, the most important thing is to be critical but constructive. So typically reviews don't come back and be like, this is the best paper ever. I wish they did. But instead it's like, well, this paper's okay, but here are 10 ways they can be better, right? Kind of thing. So it's usually critical, and so it's hard to read reviews, but you need to focus on improvement. If you're writing a review, it's best to tell people how you think they could have done it better, not just say, I don't like the way it's written, or the introduction doesn't tell a story, but it's like, I wish they had talked about this part of, the literature, that kind of thing. And be considerate always. Again, if you wouldn't sign your name to it, you shouldn't say anything derogatory, but you should try and make constructive things that are going to improve the paper. You can tell I took this, again, I forgot the citation, terrible. I took this from the Elsevier website, so they say meet the deadlines. Okay, the journal wants you to meet the deadlines above all else. I'll tell you right now, I sometimes am up to a week late. I know if I really can do it and do it well, they'll take it a little bit late. I try not to be later than that, though, because I know the author is waiting. But if something happens, like, hey, the coronavirus, and I'd accepted a few reviews, and then I spent 2 weeks trying to organize the department, and I just flat out told some editors, you're just not going to get it right now. One of them just said, fine, I'll find another reviewer. The other one waited for me. Like, if you tell people and it's like legitimate, they'll work with you. Anonymity. So when you read a paper, it's confidential, right? It's not published yet, so you ought not go and blab about all the work that you just saw. Neither should you steal their ideas. And this is one that we're going to do a case study on. A lot of times people think that, well, they read my paper and then they were really critical and they shut it down, right? So I couldn't publish it. And then they're going to go steal my ideas and go do the work. How much this really happens, I don't know. It can probably happen some, and I think it really depends on the field and how easy it is to repeat a study. Like, I work in really difficult model systems, so I don't really worry about it that much. But if it's synthesis and anybody could go buy some materials and do it, maybe it happens more often. So you have to worry about that a little bit, but as I said, ethics say that you should not be doing that. You should not be stealing somebody's work. You should be trying to be critical, but, unbiased. And that's the last one. Try not to be biased of like, oh, I like this author, so this must be a good study, or I don't like this author, so it must not be a good study, that kind of thing. And so peer review ideally helps to improve the paper, make sure that it's scientifically sound, right, and that only scientifically sound results are getting into the literature. Okay, so with that, that's the end of tonight's talk on mainly citation practices, journal impact, and peer review, and I hope that you enjoy the case studies for the week.